when we're condensing, why do I insist that after you bump up the coefficients to become exponents, that's always one of the first things I do, why do I say go left to right, two at a time? Well, because it gives you the right answer, and that's when you're condensing. To understand why I say that, let's first look at the expansion of natural log, remember that's base e, of this fraction, x over x squared minus 1 squared. So this whole thing is our argument here. This is what we're taking the natural log of. All right, so I do know from my algebra days that a over b to the m is a to the m over b to the m. So I'm going to take this. I also know that a to the m to the n is a to the mn. I've got to be really good at my rules of exponents. So this is x squared minus 1 to the first, and this is to the first. So I'm going to multiply and multiply to give me natural log of x squared over x minus 1, x squared minus 1 squared. I'm taking whatever's down here and multiplying it by itself. So that's the first thing we have to get right. Now this is my argument, and I've not made any changes. I've certainly written it differently, but it's the same thing. These are equivalent. Now I can use my quotient property to expand this. Natural log of the numerator minus natural log of the denominator. And then I can bring my exponent and make it a coefficient. 2 natural log x minus, same thing here, 2 natural log x squared minus 1. And finally, I can say, well, this is 2 natural log x minus 2 natural log of, well, I can factor this. This is a classic difference of perfect squares. So this would be x minus 1, x plus 1. And now I can expand this. 2 natural log x minus 2. Now, this is times. So if I'm going to expand this into two terms, it's going to be 2 times whatever this expands into. Natural log of a times b is going to be natural log of a, x minus 1. And this is going to be plus natural log of b, x plus 1. So I've expanded this part here, and now it's multiplied by 2, and I can distribute that out. 2 natural log x minus 2 natural log x minus 1 minus 2 natural log x plus 1. You got to be careful there because this negative 2 is going to distribute to both. So I should have a minus and a minus here. So important for you to see that. This is the expression I just got in blue ink at the bottom of my last board. I expanded that original expression out into 3 different logarithmic terms. Now I'm asked to condense it. I should get back what I started with. This is exactly why I tell you, go 2 at a time and go left to right. First take care of your exponents, then go 2 at a time and go left to right. First, I'm going to write this as natural log x squared minus natural log x plus 1 squared minus natural log x minus 1 squared. Look what I've done. I used the power property to make, in each case, my coefficient and exponent, coefficient, exponent, coefficient, exponent. I keep my negative signs. I just deal with the digit there. Now I'm going to go left to right 2 at a time. I notice this is the quotient rule. So it's going to be natural log of the numerator over the denominator minus, this one comes down for the ride, comes along for the ride. I've got this. This is my argument here. Now I've got natural log of u minus natural log of v. So when I condense, I'll have natural log of this, x squared over x plus 1 squared, divided by, that's my numerator playing the role of u today. Playing the role of v is this, x minus 1 squared. Now, of course, we can say, Well, we've got a complex fraction of the form a over b over c over d. And that's a great opportunity for us to keep the numerator, change division to multiplication, and then flip. So, of course, from our algebra days, we know this is going to be a over b times d over c. I'm going to use that principle here. So this is equal to the natural log of, I'll keep this, x squared over x plus 1 squared times, here I'm going to flip. Well, this is over 1. That's representing my c over d. So I'll make this 1 over x minus 1 squared. Sorry, I had to just make that a little bigger here. This is where we were in our last step, which of course is natural log of x squared over x plus 1 squared times x minus 1 squared, which we of course could write x over x plus 1, x minus 1 squared. Now, that would, of course, go squared there, squared there, squared there, if you're following the rules of algebra. And if you wanted to write this as a difference of perfect squares, this would be natural log of x over x squared minus 1 squared. This is exactly the expression we started with when we expanded before. If you go back in the video, you'll see that I expanded this and I contracted this. I'll only get back to what I started with if I use that rule of once my logs are all alone, meaning they have no coefficients, I condense them left to right, 2 at a time. If you just remember, condense left to right, 2 at a time, you will have no trouble. Here was our fully expanded expression. This is the error. Please don't do this. Please don't do this. Don't do this. Don't do this. Don't do it. Don't do it. This is the problem I see students follow. They do this for some reason, even though I tell them work left to right, 2 at a time. Say that you even correctly, or it doesn't have to be correctly. There's more than one way to approach this. I'm just showing you one way. Say you do this first, and you bump up those coefficients to exponents. This is what I see students do all the time. They say, well, oh, this is natural log x squared minus, let's just forget about that minus sign and bring it down. And they do natural log of this minus that must be natural log of this over that. I can understand why you would do that because that seems to follow the rules we've made. And then you could say, well, then this is this minus this becomes natural log of x squared over, playing the role of a is x squared, playing the role of u is x squared, playing the role of v is this monster here, x plus 1 squared over x minus 1 squared. And you can already see, if we keep change flip, we're not going to get the expression that we started with. It's wrong because you're just ignoring this negative. That's why I say don't do this. Don't. Do you see I started sort of randomly? I just picked something out. And because I chopped this off, I sort of ignored it and just brought it down. And I just did this. I got the answer wrong. So avoid doing this by working left to right. Here it is one more time. To condense, we're going to get each of the logs all alone. In other words, I don't leave it as n log a u. Rather, I go log a u n. I bump the coefficient up to become the exponent. That's what I try to do first. And now look, this is one log. That's why I'm saying it's all alone. It's a log all alone. It has no coefficient. And then I work left to right, 2 at a time. If you can just remember that, I think I've said it 3 times now, you're golden.